In this video we will look at fixed point binary numbers. So we have already seen the place values for a byte going from right to left, increase in the following manner: 1, 2, 4, 8, 16, 32, 64, 128, doubling each time. So this binary number represents 134 because it's one lot of 128, one lot of 4, one lot of 2 added together. Nice and easy. But this doesn't have to be the case. Particularly in the case of a byte representing a decimal number, these columns are actually going to hold different values. So to represent decimal values, the decimal point can be fixed into a particular position, and then to the left of the decimal point we can have the usual place values that we've just seen, 1, 2, 4, 8 and so on. But then to the right we use some fractional place values for the fractional part of the number. So here's an example. You've got 8, 4, 2 and 1 on the left hand side to represent the integer, the whole number part, and then on the right hand side we've got fractional parts to represent the fractional part of the number. So this binary number represents 8.375. Now it's easy to see that 8 is the whole number part of that decimal number, because there's a 1 under the 8, there's nothing under the 4, nothing under the 2, and there's nothing under the 1. Now on the right hand side it's representing 0.375 because it is one lot of a quarter and one lot of 1/8. If you add those two together you get 0.375. So here we've got 8.375. Now it's really important to recognize that whenever we represent numbers, fractional numbers in binary, it's actually far less accurate than in denary. There is no way in binary to represent 0.2. We can get very, very close by adding lots of fractional parts together, but we can't actually represent 0.2 perfectly. So let's have a look at converting from denary into decimal. It's very straightforward. Now, if you think about the whole number part, all we're going to be doing there is simply putting ones under the building blocks of that particular number. So for example, 6 is made up of a 4 and a 2, so we put ones under the 4 and 2 as we would have done before. But now let's look at the fractional part. We want to represent 0.8125. So to convert the rest, we can use the same sort of principle. What are the building blocks to represent 0.8125? Let's have a look to see a straightforward method of doing that. So we can use a subtraction method. We can keep subtracting the place values, those fractional place values, until the fraction is formed. And then each time a place value can be subtracted, we can place a 1 in that column because we know that that's a fractional value that is going to be one of the building blocks of that fractional number until we get down to a 0. And if we can't subtract it, then we'll place a 0 under that fractional part, under the column I should say. Okay, so we need to represent 0.8125 using a half, a quarter, an eighth and a 16th. So we start off with a half. Can we subtract a half from 0.8125? In other words, does a half fit into 0.8125? Is it a building block of 0.8125? Well, yes it is. If we subtract 0.5 we get 0.3125. So we put a 1 under the column, a half column, half place value, because we know that that is going to be one of the building blocks of 0.8125. So now what we do is we move on to the next place value. So a quarter. Can we subtract that from the previous remainder, 0.3125? Well, yes, we can. We can definitely subtract 0.25 from that. So we know that's another building block of the fractional part of the number. So we put a 1 under a quarter, under that place value, and then we move on. So 0.0625 is the next bit to be represented. Now, can we subtract an eighth from that? Well, no, we can't. An eighth is far too big, so we put a 0 under the eighth place value. And we see whether we can subtract a 16th from 0.0625. Now, a 16th is 0.0625. So that can be subtracted perfectly, leaving no remainder. So we can put a 1 in that column. And then we can combine all of the bits. And here we have got the fixed point binary representation of 6.8125. We've got a 4 and a 2 with a 1 underneath, so that's 6. And then we've got, as we've just seen, 8.8125 represented by a half, a quarter, and a 16th. And that's fixed point binary values. Now, what we do need to recognize with fixed point numbers is that we have to have always a compromise with the range of numbers that we can represent, if we're using a byte, for example, and the degree of accuracy. So if we use all the bits as integer values, that will give us a range of 0 to 255 possible integers to represent, but no fractional values can be given to increase the accuracy of those numbers being represented. But on the other hand, if we use just 3 bits for the integer part, that will provide only a range of values from 0 to 7. But what we can then do is actually have a fair degree of accuracy with the other bits given to the fractional part of the number. So it's always a compromise between the range of values that we can represent and the accuracy of those values.